So hello everyone. Now let's see some properties of entropy, how it works. Okay, so properties of entropy. So let's say we have y positive and y negative. So this is a two-class classification problem, binary class classification problem. So let's say case 1. Let's say we have the data set which is divided into y positives and y negatives. Okay, now let's say we have 99% of the data as y positives and only 1% of the data as y negative. Okay, then what will be the entropy? You can find the entropy of hy as it will be 0.99, I guess, so minus 0.99 into log of 0.99 minus 0.01 into log of 0.01. So it will be close to 0.0801 if you can calculate it. Okay, I'm not stressing on the calculation because you can do it on your own. Just remember to make take the log as binary base 2. Okay, that's all. So this is the value which we get. Now let's see for case 2 where you have the y positive and y negatives as 50%. 50% of the data is positive, 50% of the data is negative. How the entropy works here? So it will be 1. If you check it, the entropy of y here will be 1. Okay, and this is the maximum value of entropy which is possible. Entropy at max can be 1. Okay, and for case 3, let's say the data set is y positive and y negative and we have 100% and 1% 0%. Okay, 100% of the data is positive and only 0% of the data is negative. In that case, this hy, the entropy will be 0, and this is the minimum value which is possible, minimum value of entropy which is possible. So entropy, the value of entropy varies from 0 to 1. Okay, so 0 will be the entropy when we can very easily differentiate the data, like one of the class is 100%, another of the class is 0%. We have seen it in the previous example, right? Whenever we had like in the overcast case, you can check it, right? I'll just go back. I'll just yes, for this, see, for overcast we have 4 positive points and 0 negative points. What does it mean? 100% of the points are positive and 0% of the points are negative. Right away we can conclude that it is a leaf node and we can predict the class right away. That is the important thing which you need to understand. Okay, so here we can see the entropy when it is minimum, that means the data is data is very very differentiable, right? And whenever the entropy is maximum, which is 1, then we cannot decide or we cannot conclude what the class of the data can be, because the 50% of the data is positive, 50% of the class points are negative. So we are not sure what to predict, right? So this is the basic property of entropy, how entropy works. Okay, so I'll show you a graph. So let's say this is probability of y plus. Obviously you know the probability of y plus, if given, you can find out the probability of the y minus as 1 minus probability of y plus, right? So I'll just show you for probability of y plus, and let's say this is entropy of y. Let's say this is 0. Then how the entropy works, it will work like this. Okay, so it is basically 0.5, this is 1 and this is 1. Okay, so you can check here that whenever the probability of y plus is 0.5, that is 50%, the entropy is maximum, right? Whenever you see the probability of y positive is 1, meaning 100%, or 0%, one of them is 100, then other is 0, right? If that is the case, then we can see the entropy is 0. Okay, it is similar similar in both ways, right? It is symmetric curve, right? So here also it is 0, here also it is 0, right? That means whether it is 0%, whether the positive class is 0% or the positive class is 100%, it doesn't matter, the entropy will be 0. Okay, only when the entropy is 50 the points are equiprobable, like 50% means equiprobable. One of the class, the both classes are equiprobable, that is why 50%. If that is the case, then entropy will give you a maximum value of 1. You have to understand this. Okay, now in the next video I'll just show you another concept, which is Gini impurity, and which is mostly used instead of entropy. Okay, so see you in the next video. Thank you.